Good afternoon, everyone. So we all know that food, energy, water are very important for human well-being. And if you look at all these three systems are interconnected. For example, 70% of fresh water withdrawal goes to food production and 30% energy is consumed by food sector. Apart from this, right now, a lot of food gets wasted, either to damages or in the supply chain, food get wasted, and almost 1/3 of food produced worldwide gets wasted. Going a little bit forward, by 2050, we are going to have 3 billion more people, and population is growing, but not the land, right? In fact, we are encroaching into the land, taking over the land to build more houses or factories. So how can we sustain 3 billion more people when we cannot sustain right now the population with high quality nutritional food? So only way we can do this is by providing smart agriculture solutions for farmers so that we can increase the productivity of the agriculture. This is where the high-performance computing solutions offered by Lenovo and AI machine learning solutions that researchers are developing worldwide, putting them together to solve interesting problems in this domain so that we can increase the crop productivity. So if you look at those circles, those are not made by aliens like me. I can write program, but I cannot make those circles, right? Those circles are made because the way we are doing irrigation, and that irrigation costs tens of millions of dollars for farmers in terms of energy. Water may be free in Texas, but energy still somebody has to pay. And going forward, what is the challenge? So we have data, tons of data, and in fact, United States alone, either in situ measurements or the sensors that are placed on satellites, we are collecting data, more than 30 to 40 petabytes of data per year, right? That is huge amount of data. And even at coarser resolution, if you look at that each rectangle there, consisting of 23 million time series. And right now we have 1 meter resolution technology that anyone can buy here, and that results in 600 trillion pixels. And we want to process these 600 trillion pixels every day so that we can understand every day what is happening to the crops. And these sensors are now embedded in the tractors. So as the tractors are moving forward, you can identify if there is a problem in the crop, like weeds are growing, so that you can apply herbicide only to the location where it is being, right? So to do this, we need smart solution, meaning that as the data is getting into the system, you want to analyze and provide real-time actionable knowledge to the farmer. So that is the overall goal of this project. So to enable this project, we are looking at all the way from tiny. This is a tiny supercomputer. If you come to the back side, I can show you how we are running machine learning models here. But the machine learning model actually consisting of two components. One is computationally very expensive training the model based on expert knowledge. But once you have that model, you can push that model to the edge. So as the new data is coming, you can analyze the data in real time and make predictions on the model learned on the big computer like this. And I can give the demonstration when we go back. So the framework consists of the Lenovo AI Center where we build these models, as well as Lenovo has a product called Lico, which provides access to a lot of open source machine learning frameworks that are available. These are the state-of-art machine learning models, and we are using those models to generate tailor it for identifying crops, different types of crops, or if there is any problem in the crop. And we did this for entire North Carolina state, if you look at there. So we analyzed 933 images, is about 1 terabyte of data to build the model. But once the model is there, you can push it anywhere, on your tablet, or a tiny edge computing device that I'm going to show you to use this model to predict images. So in terms of scalability, right, two things are important when we talk about machine learning models is how much time it takes to build a model, and the second is how accurate that model is, right? This chart here shows we went all the way from 7 hours 45 minutes to 11-minute kind of scalability using the devices just I showed you earlier, all the way to data center to P900 model to P320, which is a small, less than 1 feet by 1 feet by a few inches. So we have this nice technology, and I'm going to show you anyone can now use this technology to identify different types of problems in the crops. So this is parallelization. As the number of nodes are increasing, your time to process these images is decreasing. And here are some results on even the small Lenovo tiny computing device. So what this is telling us, as you are acquiring the data of size 128 by 128 all the way to 1K by 1K, you are still certain tasks that are important, like identifying healthy vegetation versus the vegetation, the leaves are dying. So we can do in almost like real time, less than 20 milliseconds as the data gets into your system. You don't have to centralize the data in the cloud, which takes several days to process that kind of data. But this one you can do in real time. So with that, the conclusion is we have this nice technology that if you come the other side, I can demonstrate that to you.